Okay, this is a continuation of the long video lecture I tried to give as part one of the algo trading models. I had to stop it about 20 minutes ago, and it ended with a really long rant against Microsoft, which I'm not going to edit out. If anything, I'm going to add to it. I won't do it now. I'll add it to the end of this video. So if you don't want to hear any more rants against Microsoft, then when I get to that part of the video, then you can shut it off and not listen to the rant. But let's just continue with where we were. We had stopped here before Microsoft's bumbling technology screwed up my presentation. All right, this is what I was saying at the bottom, to remind you of where we were. And by the way, if you stumble across this video in the archives, this is the tail end of the video that's right next to it. So go start watching that one before you watch this one, okay? So we stopped here and we said, we're not trading this Netflix strangle. And this was a real decision, and this was a real strangle. So the summary about this in particular I want to say is, don't even think about trading options unless you have a good knowledge of and respect for both historical volatility and implied volatility, because they are what really rocks the price. How they relate and interact, how they behave, and how they trend sometimes, and how you have to adjust your strategy, or at least think through your strategy when they are doing that, especially when they're trending, as they are right now for this black swan event. Volatility will make you to force critical calls all of the time, just like it did here. Finally, my model effectively gave me information. It's a Bayesian model where I make the final decision that said, too expensive, way too expensive for the risk you have to undertake in this. So alas, we aren't going to do it. Now we'll keep searching. We'll look for Apple, Facebook, others where I tend to do these trades, and maybe we'll get into one, and we'll definitely get into one that's a little bit less expensive. I don't want to put $5,000 at risk on something as problematic as this. If this were only a $1,000 option trade, I would do a small trade just for the hell of it. But that's not our option here. So let's see what's working now in my equipment, what's not. Let's see if this is working. Yeah, this is still working. Okay, there's a couple more things that we know that to cap all of this off. We made part of that decision based upon the fact that time decay is at $3. Normally that would not be the deciding factor. And I didn't give you a time decay assignment or a model of any kind, but if you look back in that utility file, you'll see that there's a time decay utility that's shown right here. And if you look carefully at it, it says O price 1D is equal to O tranche. Now, O tranche is my brute force model that some of you have been plowing through because you've been sending me questions and email about it. So I don't use Black-Scholes for anything. I use this model. I'm going to explain a little bit about it, but we're going to go into a full-bore integration model before we're out of this class, starting with the next lecture. So at any rate, using my model, the O tranche model, which treats options, I should say, as tranches of the stock distribution. You'll see that in the next lecture. So we get this mapping for the daily time decay. And so this is another mapping model I have, but uses my own option model. So when you look at it, you say, well, it's going backwards on the index. That took me a while to figure out how to plot in Matplotlib. If I'd used keywords to look up the right value or the right thing, I could have done it quickly, but I was using the wrong keywords to try to find how to do this. So it took me about an hour and a half. So it starts with 30 days, and of course, it's days remaining going out as the option is approaching expiry. So it's inverted. So you're saying right now it's $3 per day. And then as you get down to 25 days, it's about $1.10. When you get down to 15 days, it's about 60 cents. And then finally, it finally expires worthless or the like. So this matters also clearly if you are taking positions that are long in the call or a put. And of course, in a strangle, you're long on both. If you're writing puts, to some extent, this helps work for you. But if you're buying puts and calls, this works against you. So we can calculate the value of that as well, although I didn't give you a model that specifically does that. You'll note, by the way, that on this, I'm not using the Greeks. I'm using my approach, which is a sensitivity analysis approach. I basically calculate the value of the option today theoretically, and then I calculate the value of the option tomorrow, assuming nothing changing other than the day, subtract the 2, and that's what I'm calling time decay. That's a better estimator for time decay than the Greek for that. Finally, I don't have a mapper for Vega. I've never made one up. It would take a long time to do. I thought about doing it for this lecture, and this would have delayed the lecture by at least a day. So I'm using this old stock slide here from before. Vega, of course, is the sensitivity to implied daily volatility of the stock itself, and it would be nice to have a mapping for this option, but I don't. But we know from the example I just gave you that it really is sensitive to the rise and the fall in implied volatility. So Vega is a sensitivity to implied volatility. And so we know, though, by looking at the VIX, that it tells us that when the VIX is rising, that's when you want to be long generally in option contracts. But when VIX is falling, you don't want to be long in option contracts. And VIX is falling right now. This is the more recent, this is an older mapping. This is a more recent mapping for VIX. The inset there, and as you can see, the VIX is coming down a lot. And that's another reason that we don't want to be in a strangle, because the Vega tells you that the declining volatility is a general phenomenon, and as you can see, it's been declining since the peak, since that crazy day when the Dow fell 3,000 points. That works against you, of course, because it's causing your values to go down with each passing day. So there's another reason that you don't want to jump into calls when you don't actually want to jump into any kind of long position without giving it a lot of thought if you're in an environment where the VIX is relentlessly falling, which has been the case for the past couple of weeks. Okay, let's get to the takeaways that you must understand that I end these with. This helps you prepare for whatever little quiz you have. First of all, you need to have an appreciation of the subtleties of this kind of complex strategy. And I think the biggest mistakes I see on option strategies are people don't have an appreciation for these subtleties. It's hard to make money on options. You just about have to have everything right to make money on options. It doesn't have to be model-based. I know people that trade options and do okay without big models like this, but it's no fun. And I think the models are a better approach. How many quant firms do you think just sit there and trade options without their models? But you have to appreciate the complexity of options, and that's why I like to use them as examples for modeling. You've already learned about the Greeks, but here we are emphasizing the relative importance of them, and so now you know the one called Vega matters a lot. Even though we didn't measure it, we were talking about it as we were talking about the effect of IV going up and down, and certain things you should know about their application. We applied in one capacity or the other every one of them, except for rho, because we're just assuming interest rates are zero right now. So we ignored rho, as we should be. We use divide and conquer to iterate to an IV estimator within acceptable tolerances. And if you don't understand that, go back and look at the model I gave you that does that and see how that while loop is using a convergence mechanism that I call divide and conquer. It's one I named because I developed it back in, I don't know, like the late 80s. I'm sure others have come up with the same. It's kind of an intuitive way to do it. So I gave it that name in the 80s when I first using it in Fortran programs, and then later Pascal. And the relentless pressure time decay to long positions with premiums, that's really evident when you look at the time decay graph. That's kind of a repeat from what we said in the lecture about the Greeks. But really important, and the crux of this lecture, is the subtleties and the complex interaction between historical volatility and implied volatility. That's what matters a lot, including how we've been calculating IV, partly from previous, but mostly from this lecture, how we have been calculating historical volatility, and you maybe haven't done that, even though I said you should try to do it with that little quick and dirty version. But I'm also going to give you the giant program, so you can do it with that one as well, although it'll take you some time to figure out how that program works. And you notice we are not content, especially for historical, to calculate one value. That would really be a mistake. And you can see that, I think, from the lecture. Why would it be a mistake based upon what I said in this lecture? Well, you can see that, I think, right? Why the time period chosen makes so much of a difference in HV, that's saying the same thing. How changing market positions and especially a black swan are going to affect this, and how therefore it's going to affect your trades. And then sensitivity to Vega matters right now. That's really obvious. Declining volatility as measured by the VIX. Remember, the VIX measures the volatility of the SPX, and it doesn't use the same method to calculate the volatility. In fact, the method is fairly dissimilar, but it's measuring the same phenomenon, which is the swelling of the premiums or the contraction of the premiums on the options per se. So this will give you plenty to think about. It is frozen on me again. Oh my God. See if I can get it to work. Oh, good. That's working. Maybe this is not working. So I'm not going to ask you much that is really complex out of this because of the nature of how we're doing our little quizzes at the end of this troubled semester. I'll just ask you some simple stuff. So I'm saying a lot of this right here, if you want to understand options trading or trading in general, you need to think about these things in considerable detail, and you need to understand why I'm stressing these points so much. Now I'm going to conclude with a brief rant against Microsoft. Again, I'll just make fun of Microsoft. Remember Skype, right? Microsoft bought Skype for $8.5 billion not that long ago. That's why Skype is built into Microsoft, the way Microsoft builds in stuff that you don't need and tries to push it on you. I got a little notification down here saying that OnePlus is up to date. No, not OnePlus, whatever they call their, cloud for these computers. Let's see, I got to look at it here. What's it called? It is a OnePlus, right? OneDrive. OneDrive is up to date, it says. I wouldn't use OneDrive if you had an artillery piece aimed at my head. I would never use something like that, nor will I use their defunct, stupid store, all right? I don't use anything that Microsoft provides if I can get away from it. And I'm trying to get away from even the operating system by switching everything over to Linux just as fast as I can possibly do it. That'll be my number one retirement priority. They bought Skype for $8.5 million. So now we have the one circumstance in history where you really need to have that kind of technology. And what is everybody using? They're using Zoom. Everybody's using Zoom. Raise your hand if you're using Skype right now. Well, nobody's hands up. Didn't you hear what I said? Raise your hand. How many of you are using Zoom? Oh, look, everybody has their hand up. Well, how did that happen? Skype completely dominated the market, and now in just a couple of years, the market share has switched. It's because Microsoft destroyed Skype. Listen, go to Reddit and look at all the comments that people said, I used to use Microsoft Messenger, and I used to use Skype, and oh my God, they just dismantled everything and left it. My contact list was deleted and all this and all that. That's the way they did everything. That's the way they deleted 8.1. Remember their stupid operating system for smartphones? Remember the smartphone experiment? We were all supposed to be using Windows-based smartphones, as though any of us would ever buy one of those in a million years, right? Well, how well did that go over? 8.1 was actually tied to that effort, was integrated into the smartphone effort. Talk about a spectacular fiasco. This is the company that a moment ago either figured out that I was streaming this video or just by coincidence says, because nobody's using Skype, they're trying to figure out a way to get me to join something so that I can stream my PowerPoints. That advertisement is what interfered with my feed here. I showed you the ad. I popped it in the last video very carefully. So you young people, you're going to go to work for these corporations, and you've got to decide whether you agree with the capacity or the capability and the moral bearing of the corporations you go to work for. Because you're changing the world in their image much more than you're changing it in your world. So you have to think about whether you actually want to do that along their lines. And the worst part of this is the spyware component, right? You were born into the last 20 years or so. You don't see it. You didn't live at a time when Americans were truly free and you could walk around without everybody monitoring you and knowing what you are, what your tastes and preferences were, let alone what drugs you were using or whether you were going 140 miles an hour. Nothing was monitored back then. I remind you as I sign off here, George Orwell only had two things wrong in 1984, which he wrote in 1948, which is why he chose to transpose the numbers to make it 1984. The two things he had wrong was the date. It's a little bit further into the future. And the other thing, he's assumed that governments would do it instead of assuming that huge corporations that are more powerful than governments would do it instead. So if George Orwell were to write 1984 and call it, what, 2048 or something like that, he would probably get it right. So make sure as a student, you don't contribute to the dashing of civil liberty that corporations seem to be so interested in pursuing these days. All right. I'll sign off and I'll be back with a much more complicated lecture in the next couple of days because we're going back to our roots and rebuilding everything from scratch, believe it or not. Apologies for the split video, but it wasn't my fault.